So this is the Year 7 Particles Knowledge Test. And what it is, it's all the information that you're going to need for completing the end of unit Particles Knowledge Test, right? And it's all the facts and all the bits of information, right? And it's kind of like the minimum that you need to know from each or to actually complete the test. So the idea is then you're going to go through this, you're going to fill it in, and then what you're going to do, then you're going to test yourself, and you're going to learn it ready for the testing class. Okay, so describe 3 observations for evidence in particles. First one is you've got perfume, right? So if somebody walks in the room with perfume on, even if you're not stood next to them, eventually what you'll do is you'll smell it. Boiling water, and a substance called potassium permanganate. Right, so boiling water shows particles moving, and also potassium permanganate is like a little crystal that goes in the bottom of something, and what they do is they also gradually move around. Complete the particle diagram, solids. Right, now what I'm going to do in this is I'm going to be a bit lazy, right? So solid particles, nice and ordered, should all be pretty much the same size really. I'm just being a bit daft with it. In a liquid, right, they're kind of there, right, but what there is just a little bit more higgledy-piggledy. So what they are this time is they're not in rows, right, all the particles should be approximately the same size, but the kind of little gaps in between. And gases, just draw 3, what they will do is they're moving around fast, right, and there's nice big gaps in between everything. Describe the particle arrangement, right, so we'll do arrangement first. So solid is regular and orderly. Okay, regular and orderly. Liquid, random but close. And a gas are disorderly and random. Okay, they're kind of all over the place. Energy, let's do energy in red. Right, energy is kind of like low energy, the particles are just kind of vibrating. Liquid, medium, it's difficult to actually put a judgment on it. And then for gas, they're high. Movement. Solids vibrate in a fixed position. A liquid, the particles are sliding over each other, and in a gas they are random, free to move. Final one, attraction. The attraction between the solid particles is very strong. In a liquid it's strong, and in a gas it's very weak. Right, draw and label the states of matter diagram. Okay, right, so we've got our solid, we've got our gas, and we've got our liquid. Right, so if we go for the obvious ones first. So gas to a liquid is condensation, right? You know, like water appearing on a window. Liquid to a gas is evaporation, or you could have boil. A liquid to a solid is freeze, think about water. Solid to a liquid is melt. And then the 2 weird ones that I'll do in blue is solid to a gas is, I'll just write it up here, sublimation. Okay, so that is then a solid to a gas, which is that arrow. And that arrow there is deposition. Right, so if you think about it, deposition, deposit, so a gas gets deposit as a solid. Right, and a good example of that is dry ice, which is carbon dioxide. Well, no, the sublimation is. Right, so what you've got is you've got dry ice as a solid, and what it does is you leave it there, it misses out the liquid phase and goes straight to gas, which is sublimation. Right, temperatures. Cesium, right, state at 25 degrees C. Now the way that I always do this is I'll draw myself a number line, right, and then what I'll have is I'll have kind of if I do cesium at 669, and then I'll do 29, right? And then so above that is a gas, below that is a solid, and anything in between is then a liquid. So if I look here at cesium at 25 degrees C, the 25 degrees C is lower, so therefore it's a solid. Bromine, it's in between those two numbers, so it'll be a liquid. Oxygen, it's not in between those two numbers, it's a gas, and what you could do yourself a number line like I just did. Strontium is also not in between those, draw yourself a number line to try and work it out. And xenon is also a gas. Okay, but the easiest way of doing that is just to draw your number lines, where the number at the top, so for example strontium again could be 1, 3, 8, 4, draw yourself a number line, then it melts at 7, 6, 9, so in between those numbers is a liquid, above those numbers is a gas, and below those numbers is a solid. Okay, draw a labelled heating graph of water, so line, across, should be using a ruler really, line, across, and then potentially a line. So at this point here, it's a solid. At this point here, it is a liquid. And at this point here, it's a gas. Then we've got to do is we've got to chuck in our words. So liquid to a solid, freeze. Solid to a liquid, melt. Liquid to a gas, evaporation or boil. Gas to a liquid, condensation. Right, and this bottom axis here is energy increase. Describe the effect of temperature on the rate of diffusion. Right, so the rate of diffusion. Right, so diffusion is faster at a higher temperature. It's mainly due to the particles having more energy. Okay, makes sense really, doesn't it? If you add in heat to it, the particles are going to move faster because they've got more energy, so therefore diffusion will happen quicker. Describe 2 ways to demonstrate the effects of atmospheric pressure. You could have a ruler and paper, and you could also have collapse a can. Okay, 2 ideas about atmospheric pressure. Explain what happens to the pressure of a gas if you reduce the volume. Right, if you reduce the volume, right, then there is less space, to move around. Therefore, there'll be more collisions with the side. Okay, and what that will do then is that will increase pressure, because what you're doing is you're squashing more particles into a smaller area, right? So then there's going to be more pressure because the particles are heading to the outside. Right, keywords. The temperature at which a substance boils is obviously the boiling point. The process by which a substance changes from one state to another is the change of state. So change of state, which is one state to another. The temperature at which a substance melts, melting point. A material whose properties are not the same all the way through is a mixture. And then the 3 forms, solid, liquid and gas, are the states of matter. Now what they are is that video is then all the answers to the end of unit knowledge test. And what you need to do now is you need to make sure you filled it in correctly. And then there's another video in here that then says about blank. And what it is, it's a blank one of these. Go through the video, write down your answers for each one of the individual questions onto a piece of paper, right? And then check your answers. If you get anything wrong, do it again, right? So the whole point in all this is repeat. Just keep on repeating and repeating until you get everything then 100% correct.